Hey guys, welcome back. For this video, I'm going to explain to you how to interpret your linear model and how to make sense of the data you're presented with. So here we have some functions and it's asking us to use the concept of bacteria growth in a lab as our background information. Alright, so we know a few things about this. When it comes down to our function, we know the general equation y equal ab to the x, where a here is your initial value, b here represents your slope, and your slope could be growing, where b is greater than 1, or your slope could be decaying, where b is less than 1. Alright, so let's bear those concepts in mind. So when we have, let's put some hat above these because these are basically predictions. So when we have our function, for example, y is equal to 40 times 1.5 to the x, and let's say this growth is, let's say the growth and decay is daily. Let's say the explanatory variable represents days. So let's say days for the top part, and let's say minutes, let's say hours for the bottom part. So this section below here, we're going to consider these as bacteria growing hourly and decaying hourly. And the top part, we're going to consider them to be bacteria growing daily. So here, y is our explanatory, our response variable, and that's the bacteria in the lab. And we have days representing x. So let's put up here. So y representing the bacteria, and let's say x representing the days. Alright, so to interpret this, we need to say what is the initial bacteria in the lab. So we're going to say the initial bacteria in the lab was 40, right? And since that is a 1.5, we know it grew. And it grew by 1.5, convert this region here to a percent. So 0.5, you move 2 places to your right. So that's 50%. So we're gonna say it grew, it grew on a rate of 50% daily. Right? So it grows 50% daily in whatever lab they're in. So here you tell me initial value and you tell me the growth rate and daily as x increases. So you're basically telling me as x increases, this value is going up by 50% of whatever is there. And x here can take on any number of days, and you basically find the answer when you substitute them. Very soon I'll explain some of that to you. Alright, let's continue with this one. So this one says y is equal to 67 times 0.9 to the x. Remember, a is your initial value, b is your slope, either it's growing, greater than 1, or decaying, less than 1. So let's do this question. I'm going to erase this aspect here. So right here we can say this is the lab started out with 67 bacteria, right? Here it's a 0.9. So we know that this is a decay of 1 minus 0.9 to give us 10%. So we can say its decay rate is 10% as the days increases. Alright? So again, when you're writing your explanation, it's based on how you speak, you write. You don't have the same thing as I do. So the lab started out with, so it's up to you on how you write. You can go ahead and just work it like that. So the lab started out with 67 bacteria. Its decay rate is 10% as the days increase. So different wording, just apply the same meaning. Okay, this one, so the lab started out with 5 bacteria. Again, decay by 12% on a daily basis, or you can say decay by 12 as the value of X increases. You can say something like that. Alright, let's talk about this one down here. I want to do this one first because these are similar to the top one. I want to do this one first. So this one says y is equal to 4 times 1.054 to the x. Here, I do the same thing. So since it is bacteria in the lab, and x represents hours, compared to this one that says days, we're going to do a different wording. So here, we're going to say the bacteria in the lab started at 4. Again, we need to know the growth rate. It grows 0.054 would be 1, 2. So it's 5.4%. So it grows 5.4% hourly. Let me spell right, Hourly, hourly, as the, so it grows 5.4%, hourly, we could say as X increases. Yeah, because the more the hours go up, the more it's going to increase. Yeah, we could say that as X increases. And you may be wondering how I got the 5.4 here. I'm going to come at this and talk a little more about that. So 1.054 is your D value. We convert this to a percent, we move 1, 2, or you can multiply by 100. You should get 105.4%. Remember, the extra from 100 will tell you what's the growth rate. So if you say 105 minus 100%, that will give you 5.4%. And this 5.4% here would be your growth rate. And so all the others are similar to the one at the top, so I won't be going through all of those. But the concept remains the same. The starting or the initial value, then you tell me the decay or the growth rate and how fast it's increasing at a particular rate. And that's basically how you interpret your exponential model. If you have any question, feel free to leave me a comment in the comment section below, or you go ahead and send an email or whatever the case is. And I'll see you guys very